Question 7. So for part A, I'm being asked to find the direction of motion of P. Now the velocity of P is 9I minus 2J, so that's 9 across and 2 down. So using SOHCAHTOA and tan, I can see that this acute angle here is inverse tan 2 over 9, opposite over adjacent, is 12.5 degrees. But as the question is asking me to give my answer as a bearing, I need to take this from north, so I need to add on this extra 90 degrees up here. So it's 90 degrees plus my 12.5, which is 103 degrees to the nearest degree as required. Now for part B, I'm being asked to find an expression for P and for Q. So for each of these, you start off with the opening vector. So where do they start their journey from? Well, that's 9, 10 for P and 1, 4 for Q. And then it's t seconds worth of their velocities. So for P, that's t lots of 9 minus 2, and for Q, it's t lots of 4, 8. Now it'd be perfectly alright to give your final answers in this column vector format, or if you want to give it in IJ format, which is fine, it doesn't specify which you need to use, those will be your two final answers. Now for part C, we're being asked to show that Q to P is this expression. So think about it. How do we go from Q to P? Well, we go from Q back to the origin, and then from the origin to P. So I'm going to use the position vectors of OQ and OP to do these. So Q to O is the opposite of O to Q. So here's our position vector for Q, for Q, so that's O to Q. Remember, position vector is always from the origin, so this answer I've got here for B part 2 is my O to Q. So my Q to O is going to be the opposite of that. So that's minus 1 minus 4 plus t times minus 4 minus 8. So that is Q to O. Those two there. Not O to Q, that's Q to O. And then secondly, my O to P is just my P position vector. So I've just literally just copied that bit out there to get this here. Then adding the two together, so obviously just adding the opening part, I've got minus 1 add 9 is 8, and minus 4 add 10 is 6. Then adding the t components, I've got the minus 4 add 9 is 5, and then minus 8 minus 2 is minus 10. So that would be it in column vector format, but obviously I need to show this in IJ format. So just rewriting that, I've got 8 plus 5 lots of t for the I component, and 6 minus 10 lots of t for the j component as required. Now for part D, find the values of t when the ships are 10 kilometers apart. Now they're 10 kilometers apart when QP equals 10. So just think of this in terms of Pythagoras. We need the I component squared plus the j component squared to equal the hypotenuse squared, to equal QP squared, so to equal 10 squared. Okay, so we're basically saying the amount along the corridor squared, 8 plus 5t squared, plus the amount up or down the stairs squared, 6 minus 10t all squared, has to equal 10 squared. So that's the key bit to answering part D. So that's just simply Pythagoras. Alright, that amount along plus that amount across. Alright, each of those squared gives us the hypotenuse squared, just straight from Pythagoras. So then it's just a number crunch. So 8 plus 5t all squared is 25t squared plus 80t plus 64, and 6 minus 10t all squared is 100t squared minus 120t plus 36, and obviously 10 squared is 100. So then gather up like terms, we get this. Dividing through by 5, we get this. And then factorizing, we get this. So our two values, notice in part D it said values, so we had to be on the lookout for two answers. What makes this first element naught? Well, obviously that's t being naught. And then our second solution comes from this bracket equaling naught. So that's 8 over 25, which is 0.32 seconds.